Hello students. So today we are going to begin to look at this unit known as basic geometry. Now as we know, geometry is a huge branch of mathematics that study a lot of things, all the various shapes. Those are something that you actually are familiar with, right? So other than shapes, sizes, and even positions of two-dimensional, three-dimensional objects, these are things that we have all under the purview of geometry, right? Now, today, of course, since it says basic geometry, we're not going to go into so many things. Don't worry. Let's start with the first things that we do when we talk about geometry, right? Because the idea of geometry is we want to measure things, right? So we want to measure some stuff. What are we measuring, right? So depending on the objects that we're looking at, if you are looking at a simple two-dimensional diagram, we'll be measuring things like length, we'll be measuring things like the angles between two lines, right? So those are things that we are going to figure out. So here you have your actual physical notes with you. I hope you have. So we can go through this together, right? So let's begin. So some of the big ideas that we covered: notation, how do we actually label things properly in the geometry, as well as to how to interpret diagrams, and what are the things you are going to measure, right? So let's take a big picture of what a geometry is. I think we are quite familiar with this. Geometry, first of all, the word itself, right? Geo means earth, and metry come from the word metron, which means to measure. So we measure things that we can find on earth. What are we measuring? We are measuring precise things, right? So we want some precision, some standard things we want to measure. Some things we measure will be time. We measure time, how fast something is. We measure the mass, how much matter an object have, right? And we measure length, how long. Okay, so some of the things that is under geometry, we study angles. This is something that we will look at in details. And in our syllabus, angles have two different units: degree as well as radian. Are there others? Maybe not, for you to find out, right? But these are two that's in our syllabus. And we also talk about things like understanding points. That's where the Cartesian coordinate system is all about, something that we'll look at earlier this year. So points have 0 dimension. We also talk about lines, right? Lines are one-dimensional objects, right? And under lines, there are actually lines, line segment, rays. We actually mentioned that in class. You're familiar with that. And some of the behavior of lines will be things like the lines, they do intersect one another. Now we talk about parallel lines. We talk about perpendicular lines, right? And also figures, we talk about two-dimensional objects. So two-dimensional objects will include things like your triangles, square, quadrilaterals, circle, right? Then after that, you have a trapezium, parallelogram, rhombus, etc., etc. Right? All the different types of polygons, right? Three-dimensional objects you'll be looking at in your syllabus include things like all the prisms and cylinders, pyramid, cones, sphere, etc., right? And of course, some of the relationship between all the different measures, we talk about distance, right? So distance, things like circumference and perimeter, we'll look at areas, surface area, okay, total surface area, or area of two-dimensional objects, as well as under space, we talk about volume of an object. So these are things that's actually covered under geometry. So I hope you have a good idea what geometry is, but let's see what is the focus for the initial part of this unit, right? So the initial part, let's talk about angles. Okay, so we know what angles are. We use them in our daily life quite a lot, right? But angles, they do have names for different magnitude of angles. So if an angle is in between 0 degrees to 90 degrees, okay, we call them acute angle. So let's get all these vocabulary out so that when we refer them as we continue our course, you're familiar with them, right? So between 0 degrees to 90 degrees, we call them acute angles. Right angles is actually 90 degrees. Okay, so another word that we should be familiar with. Obtuse angles will be from 90 degrees to 180 degrees, right? So we're in between 90 to 180. Now, a straight line is actually 180 degrees, right? A straight line is basically two right angles adjacent to each other. And then if it is more than 180 degrees, right, we call them the reflex. And down here, we will just stop at 360 degrees. Why? Because 360 degrees is equivalent to 0 degrees, right? We know how that works. Of course, do we measure things that's more than 360 degrees? Yes, maybe, right? When we go into pre-calculus sometime in your future, okay, when you learn about additional mathematics. But for now, we will just stop here. Okay. So here, when two angles are placed adjacent to each other, I hope you know the meaning of the word adjacent. It just means they are side by side, right? If the adjacent angles add up to 90 degrees, they have a special name, okay, a unique name. They are called complementary angles. So complementary angles is when the two adjacent angles, they add up to 90. And when we have angles that add up to 180, we call them supplementary angles. So these are some of the vocabularies that you will encounter when you are actually studying this particular unit of geometry, right? So some of the big ideas: geometrical diagrams contain information that help us to visualize relationship between points, lines, and angles, right? So we'll be looking at quite a few diagrams in this particular segment. Okay, let's carry on then. Right, some of the angles have certain properties. So what are the properties that we will want to look at? So here are some of them that you should be familiar with. Okay, so if we say that there's angles on a straight line, okay, what it really means, right? So the name, you can see on the first column of this table is the name. Then the meaning is in the second column. And you know, we talk about diagrams, so the diagrams on the third column. So on the first column, you see angles in a straight line. What it means is that the adjacent angles on the straight line, the sum is actually 180 degrees. Okay, so that's what it means. You can see them in the illustration. I think we can understand this quite easily. Next, if we say angles at a point, what we really meant is that the sum of the angles around a point, okay, add up to 360 degrees. Okay, this is also quite easily observable based on the illustration, right? Now, the third one is something interesting: vertically opposite angles. So what happens if we have two straight lines intersecting one another? Okay, the opposite angles in this case, right? You can see the angle P and the angle Q. They are actually equal, right? So we call this vertically opposite angles. How do we know they are equal? I mean, if you observe, right, this angle over here that I'm marking out in red on your screen right now, right? This is actually adjacent to P, right? So it's 180 degrees minus P will give me the angle that's marked out in red. And then after that, 180 minus P is actually, when you add Q to it, it goes back to 180. So from here, you can see that P and Q, they must be equal to each other. Okay, I hope it makes sense to you. If not, well, remember these facts first, and we'll figure it out again when you actually try out some of the examples and exercises, right? Okay, so based on what we have learned, here's the first activity that you can try it out. So if you would like to pause the video and try it out first, you can, right? Then after that, you can continue the video to actually follow along to see if you're on the right track. Okay, so this is the activity. What does it say? It says find the value of B, and you were told that the line CM, DM, EM, FM, they are straight lines, right? So what equation will you form to find the value of B? Well, to find the value of B, what can we do here? Okay, so if you were to observe carefully, right? Let me mark it out with my highlighter. Okay, this line looks straight, right? Whereas the other two not so straight. Okay, so let me highlight in another color. This one is not straight, right? So the thing is, the question did not say that DF is a straight line. Although sometimes if you are too eager and too quick, you may think that they are straight line and you apply the vertically opposite angles. That's where you fall into a trap and you will not be successful. So here you got to be careful, right? Now, CE looks straight as well. However, right, the question did not specify. So this is the first thing I want to mention, that most of the time when you see diagrams like this, if the question did not specify, we should avoid assuming that they are straight lines. because they could be almost straight line. I mean, 179 degrees or 181 degrees. You never know, right? So it's safer not to assume that they are straight line from the offset, unless it's explicitly mentioned in the question. So in this case, instead of using vertically opposite angles or even angles on a straight line, I would use angles at a point, right? So the property that I will use will be, let me bring out my pen, angles at a point, right? So if I do that, okay, what happened is I could just add them all up, right? We have 4b minus 21 plus 3b minus 14 plus b plus 34 plus 2b plus 1. I add up all these four angles and they will add up to 360, right? So this is what I do, and we can from there just solve this algebraic equation to obtain the value of b. Does it make sense? I hope it does to you, right? Okay, so here are some of the arguments that some people may have, right? So in this case, we have the first person, Joseph. Joseph says that we can use vertically opposite angles. We have already explained this is not a good idea because we should not assume that the lines are straight if they are not mentioned, right? Okay, now over here, okay, who is this? Anthony. Anthony says the sum of 4b minus 11 and 3b minus 14 is 18, 180. So let's take a look. So 4b minus 21, 3b minus 14. Now this one visually it is possible. However, once again, okay, we should not assume, right? We try not to assume unless we don't have a choice, right? Don't assume that it's straight line because the question did not say so. Okay. Whereas this is the one that we talk about, the sum of all four angles add up to 360. So we're going to use this. So we actually adopted the argument used by Alex, right? And if you work it out, Paul just have already worked it out. So actually Paul is correct because I had worked out this question. But if you have tried it on your own, I hope you did also get 36. And George says that it can be solved by 3 different methods. No, not really, right? We just stick to the one that is foolproof, and that's the one that's provided by Alex in this case. So what we are dealing with is sometimes we have the diagram. Just because the diagram is there, we be careful about the assumptions that we make in order to approach the diagram. So if the information is not explicitly stated, sometimes we avoid assuming, right? And there are also many times where geometry questions, there are more than one approaches. So we try to actually choose the one that makes the most sense and make the least assumption actually. Okay, so let's move on. Right, here's the next activity. Right, so here we are told that AOB and COD are straight lines. So this particular one, see, this is an important piece of information because we are told that they are straight lines. So now we can actually use some of the other techniques such as vertically opposite angles as well as angle on a straight line. So in this case, if I want to find the point A, what can we do? Well, right, what I will do is actually to realize that 7A, right, 7A over here and 103 over here, they are angles at a straight line. So I could just add them up, right? So the property I will use is angles, okay, on a straight line. This is what I can do, right? Alternatively, we can actually find B first using vertically opposite angles, but let's use the most direct approach, right? Let's say, okay. So here, again, we have 2 recommendations, one by Joseph, yep, and one by Paul. So what did they do? Let's take a look. Joseph actually Joseph actually need some work here. He actually started by saying 2b plus 13 plus 7a is 180. So let's take a look. 2b plus 13 plus 7a is 180. So technically he's not wrong. However, okay, he actually uses 2b and 7a in the same equation, which means he actually have to find the value of a before he finds the value of b. Whereas the method used by Paul, okay, Paul used vertically opposite angles and declared that 2b plus 13 equals to 108. Okay, so what happened is we have already found a, right? So a is found. Let me highlight it. Okay, using what I've mentioned, using the method of angles in a straight line, okay, is in yellow. All right, I just realized that I spelled angles here wrongly. Allow me to change that. Right, so we have found A. So after we found A, right, there are two different ways that we can find B. But in this case, personally, I would prefer using Paul's method. Just in the event that I accidentally calculate my A wrongly, I will still get the full credit, right? In this case, I do not need to use A to find B, okay? But sometimes it is necessary. So it's not saying that Joseph here is wrong, just that Paul's method is actually safer. So like I mentioned, quite often we have more than one method to solve this type of question. It takes a bit of experience to actually decide which one to actually use. Okay, so here's my recommendation for you. I hope it makes sense to you. Let's move on to the next section. So in the next section, we are just going to practice a couple of questions using the properties that we have talked about. So let's begin. So we have a question over here. We are supposed to find the value of the unknowns. So there are a few unknowns there. There are two. There are B and there are C, right? So what can we do here? Well, let's start with trying to figure out what B is, right? So if you look carefully, right here, we can actually make use of a couple of things. I'm going to start by saying that angle, and bring out my pen, angle AOE, right, which is this angle over here, let me draw it on the diagram in red, right, is equals to B, right, B degrees. And the reason is because they are vertically opposite angles, right? So we got that. Okay, so once we have that, what do we know about this part here that's in red, right? So this is useful information. So once I have that, I can use angles in a straight line, right? Let me highlight it for you on the diagram so you can see. You can use this portion here, this portion here, and this portion here. We know that they add up to 180 degrees. We are told that it is a straight line, so we can do that. So let's do it. So we have 2b, right? 2b degrees plus b degrees plus 2b degree plus 15 degrees. This is equals to 180 degrees. Okay, please remember, provide the reason. In this case, it is angles on a straight line. Right? So simplify this. We have 5b degrees equals to 180 degrees. Right? B degree equals to 33 degrees. Well, take note that this is still in angle, so B is equals to 33. Right? We found our B successfully. Okay. So from here, it'll be quite easy to find C now because I think you can see it as well. Most of you should be able to see it as well. 3C degree is equals to 2B degrees, right? Because they are vertically opposite angles, right? So 3C will be equals to 2 times 33, right? B is 33, so 2 times 33. Therefore, C is equals to 22. You just have to work your algebra. There we go. Right, so that's the first question. I hope you have been successful. So another question. So once again, just to remind you, when you encounter questions like this in this video, feel free to pause the video, try out the questions on your own, then after that resume the video and compare answers with mine, just to check if you have been successful, right? And do any corrections you may need to. So let's move on to the next question. So the next question, the diagram is given, and we are told to find the values of x and y, as well as to find the obtuse angles and the reflex angle accordingly. So let's do that, right? So let's do part 1 first. Right, oops, there's a highlighter. Let's change back to pen. So part 1, okay. What I can do now, right, if I take a quick look at the diagram once again, we can actually find the angles. Which angle can we find? Right, we can find BOC. We can talk about BOC first, right? So angle BOC, right, is going to be equals to angle AOB. Does it make sense? BOC, AOD. I wrote wrongly. Let's go back and change that. AOD, right? And the reason is, of course, vertically opposite angles. Something that we are familiar with by now. Vertically opposite angles, right? So now BOC is actually 6x, right? And AOD is 34 plus 186 minus 4x. So let's simplify this. 6x equals to 34 plus 186 minus 4x. That brings us to 10x equals to 220. X equals to 22. Successful. So we got the value of x. Now we can proceed to find the value of y. So how to get y? Once again, observe. And then we can do something like, okay, 6x plus 3y is going to be equal to 180 degrees. But of course, we should always, okay, explain why that is so. This is angles on a straight line, right? Then that's why they add up to 180. So since x is 22, 6x is 6 times 22 plus 3y is equals to 180. So 3y is 180 minus 6 times 22, and that brings us to 48. Therefore, y is equals to 16. So we have successfully found our x and y, right? So finally, just to answer the question, obtuse angle AOD, right? So we just part 2. Therefore, angle AOD, right? AOD is equals to, is equals to 34 plus 186 minus 4x, right? Which is equals to, replace the x with 22. I'll need my calculator for that. Right, calculator, where are you? Right, 132. That's what I got. 132 degrees. So take note, right? So if I'm trying to find the value of x is equals to 22. So I do not need to write the units over here. However, when we are finding the angle AOD, now angle, when they ask for an angle, you have to give your solution with the units, and the units is degrees. So there is a difference. So I'm using this example to actually highlight this point. If we are just trying to find an unknown letter like x or y, our solution will just be a number. But if the question asks for an angle, we give our answer with the degree, right, with the units. So please take note of that, which is why part 2 is 132 degrees, whereas part 1, x is just 22. Okay, so similarly from here we find angle. Let's write the word reflex as well, right? Reflex angle COE, right? So COE, the reflex angle will be the external part, right? The part that's more than 180 degrees. So in this case, it will be 6x plus 3y plus 186 minus 4x, right? Degrees. So it's in all right, so write degree here as well, right? Have the units there. So again, just replace the y with 16, replace the x with 22. Use your calculator. You should have, let me see. Well, my calculator says 278. I hope I pressed it correctly. If I'm wrong, just let me know in the comments. I will update this in the future, right? So successful, got it. Okay, I hope you have been successful as well. Well, so moving down, right? Assignment. Yep, you do this separately on a foolscap paper or worksheet. I see whether I can prepare worksheet for you. If not, you do a foolscap paper. I will let you know in class, right? So you get this done. And that concludes part 1 of this lesson, of this chapter, or this unit, whatever you want to call it, right? So that ends part 1. I'll see you in part 2. Have a nice day.